be a little bit clearer for me. Thank you. Sorry to interrupt.
Okay, I think should be right here. Do you hear me? Good. So, hello everyone. Hope you have a good evening here. My name is Alexander. I work for Rantis, and today we are going to speak about an application catalog for OpenStack. We call the thing Murano project. So this is our agenda for today. We'll talk a little bit about why do we need this application catalogs at all, and what are the use cases and what are potential business values which can be brought by application catalog to the end users. Then we will look how we have implemented this approach. We'll look how we built Murano as an application catalog and how it works. We'll do a deep dive into Murano's architecture. Then we'll have some practice. I'll demonstrate how Murano works in practice. I'll have a cloud application being deployed by Murano and being cataloged by Murano. And after that, I'll answer your questions. But first things first, let's start from the very beginning, from the OpenStack. Alex has already stated some of highlights of OpenStack, but let's just make sure that everybody understands that. That's really important. OpenStack is no longer those geek-driven homebrew solution like let's have our own Amazon with bells and whistles. Well, it used to be this sometime before, but now it's becoming more and more mature, more and more solid. It's becoming a serious player on infrastructure as a service market. It has a number of customers who adopted it, number of enterprises who are working with OpenStack, and eventually it will have more. And the core components of OpenStack, the infrastructure layer of OpenStack, is pretty solid. And so, as Alex has mentioned, it's moving towards the platform as a service direction. The platform as a service is becoming a serious business here. There are already a number of platform as a service solution, commercial platform as a service solution, which integrate with OpenStack. And there is an initiative to create a native platform as a service solution for OpenStack. Probably heard about the Solon project. And this means that the progress is moving towards the next layer of cloud stack to the applications. Right. But actually, cloud infrastructure is useless without this application. So we have built this, we have built OpenStack, and it works quite fine. But without the applications to run on top of it, to utilize its most capabilities, the infrastructure just doesn't bring any value to the customers. So actually, the success of OpenStack will eventually depend on the developers. So up to you, folks. Remember this guy and his full words? Yeah, developers, 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 developers. And that's it. There are a number of developers in OpenStack, and it's more and more every day. Just watch the OpenStack dev mailing list. You'll see that more and more new names are coming. And developers, well, they usually develop apps. And this means we're going to have a tremendous amount of applications very, very soon. We have a lot of them already, and we'll get much, much more. And, well, building cloud application is quite a complicated process, but we all know how to do that. We know how to build applications. We know that there are tools, there are frameworks, there are libraries. As I said, there will be a Solon project which will help developers to have their apps built. But once it's built, there is a new challenge. The application has to find its customer. Well, there are hundreds of applications, as I said, and there are thousands of customers. And all of them have different requirements. Application has dependencies, application has prerequisites, software specs, hardware specs, licensing, all those stuff. And customers, they have their business cases. They have their scenarios. And it's quite hard to bind them together. So eventually, there is a need to have a single point where these needs will meet. That's an application catalog. So it will be actually a single point where the application developers will be able to publish their work, to publish their the application they create. And then, once the application is published in such a catalog, it should be searchable and browsable by end user. Once found, this application should be easy to deploy, and it should be deployable in the cloud infrastructure managed by, operated by that end user. So there should be no gap between the application catalog, which just lists the applications, and the cloud infrastructure operated by the user. It should be seamless deployment. And of course, last but not least, let's not forget about the money. The developers, well, we usually want to eat something, right? So we want to get paid for our work. We want to get paid for the applications we create. And this means when our application is used by some application catalog and is deployed in some cloud infrastructure, the application developer has to get paid. I think you already got the idea. I'm speaking about the App Store. An App Store, not for iPhones, but for OpenStack. Let's a little bit dive deeper inside the use cases of this OpenStackish App Store. So it all starts with the application developer. When he got his application ready for the cloud, he wants to publish this application in the catalog. To do it, the developer has to describe it, define all the configuration parameters and all the dependencies of these applications from other applications or from the cloud infrastructure. Then, the next step will be to create the workflows which will deploy this application in the cloud infrastructure. And not only deploy, because as I said, the catalog has to manage the whole life cycle of the application once it's deployed in the cloud infrastructure. There are various kinds of actions which are cloud specific and which have to be kept in mind when we say about the applications and clouds. There is data migration, there is auto-scaling, there are backups, well, various kinds of health monitoring and all those stuff which has to be created in a unified manner and has to be manageable by application catalog and by end user which uses it. So the developer has to define all those workflows to support all those scenarios. Then this description altogether with these workflows and with the application itself should be packed in a single entity which we call application package. And then it should be submitted into the application catalog and indexed there. So here we come to our next customers, the cloud users, the people who use application catalogs. They want their applications. They want to locate them in the catalog, inspect their descriptions, inspect their software and hardware requirements, check the pricing, check the end user licensing agreement. I don't know, are there any people who read the end user licensing agreements? But, well, I hope they will. And, well, eventually, as I said, this is kind of an app store. And the end users should interact with our application catalog in the same way we interact with an app store. What we do, we locate the application here, and then we just press a single button, install. Well, the same should happen in application catalog. Of course, it's a perfect world situation. We are speaking about the huge applications, well, usually huge, and we are speaking about enterprise-ready solutions. So most probably some of our applications will not be installable just by single click of the button. Probably they'll have to be at least somehow configured. But what we want our end users to be able to do it as easy as possible. Because, well, our end users are not professional DevOps guys. They're not professional cloud administrators. Most probably, they're just regular users having their business cases. And they don't care about the IT, about infrastructure, so they just need to fill in the required properties and have the application up and running in their cloud environment. And the third group of the users who will benefit from the existence of App Catalog are the cloud administrators. They act as a mediator between end users and application developers. They approve the application packages being submitted into the cloud. They approve the requests of the user to use these application packages. They manage the access rights, they manage the access policies, and well, eventually they gather the money from end users and pay the salaries to application developers. So the actual use cases may differ if we are speaking about private clouds or public clouds. So this process and this role should be quite customizable and flexible, but eventually you've got the picture. So that was just a concept, and now made the Murano project. That's our implementation and that's our implementation of this vision, of this concept. Actually, we have started from much simpler goal. We were building a tool which would catalog and deploy the services for building Windows data centers in the OpenStack clouds. And eventually, this worked, and we were quite successful with that. We had a couple of successful installations with customers, and then we realized that this goal is much wider. That while we were doing that, we have implemented a lot of things which map to this generic application catalog mission which I have described. So we just decided to improve Murano, so it may become a real application catalog serving not only very specific class of use cases deploying Windows, but become a real catalog for various kinds of cloud-ready applications in OpenStack, targeting different operating systems, different programming languages, and, well, all the kinds of the use cases I have described. So let's look at Murano at its current stage and what it can do and what it does and what it will do in the future. So Murano manipulates with entities which we call application packages. These are structured and annotated and signed archives which contain the definitions of these applications. These definitions which I told you about when I was speaking about developers' cases. In our case, of course, we want some generic application properties, the descriptions, the license, the version information, all those stuff. But to deploy the applications in the cloud, we rely on underlying core OpenStack components, such as heat, for example. And that's why one of the crucial components of Murano application packages are heat templates. Actually, a snippet for heat template. Because Murano, when it deploys the application or a group of applications in the cloud infrastructure, it dynamically generates a heat stack out of a number of little heat template snippets, and then deploys the cloud infrastructure using this heat stack. Also, we are doing the on-VM configuration, on-VM software installation, and other actions which should be done on the deployed virtual machines. So, of course, these operations are done by various scripts and agent-side programs, which we also put into the application packages. And the binaries, of course. Sometimes you can deploy the application from external source. For example, on Linux machines, on Ubuntu, you can just execute apt-get command and you'll get your application. You'll have to configure them, but, well, the deployment of actual binary is solved by the external source. In Windows world, there are different problems. In the world of Java applications or PHP applications, there is no binaries for PHP, for example, but still the application itself may be put inside the application package as well. But the core thing is a workflow which manipulates all those stuff, which manipulates the binaries, manipulates the heap templates, manipulates the deployment scripts, and makes the whole thing work in the cloud. Another entity of Murano is Murano environment. That's what we call a group of applications deployed in the cloud. Important thing is that applications may depend on each other. For example, on this diagram, you see that we have an examples of 3 different cloud applications. Some My Java applications, that's some custom application created by some user of our cloud, and 2 generic ones, a Tomcat server, servlet container, and MySQL database. From Murano's point of view, all of these are Murano applications. And they may be interdependent. So the Java application requires a Tomcat servlet container to run on, and it requires a MySQL database to store the information in. So these 3 applications form an environment because they're interconnected, they have to communicate, they have to share common network resources, and probably some other resources. And here are these resources. You may see the compute nodes on which these services are deployed, and this is a network. And of course, there will be much more. I just didn't put it on this diagram for simplicity, but there will be shared IP addresses, there will be subnets, there will be security rules, there will be firewall configurations, and all the stuff which form a really production-ready application environment. And so these interconnected entities are components of Murano environments. And when the user composes this environment, he just builds a definitions of these entities. And then, when it's ready to be deployed in the cloud, Murano does the rest. Murano deploys all the entities using various deployment mechanisms, using heat, using on-VM site configuration, all those stuff. Important thing here is that we want, as I have said when I was speaking about user experience, we want the user to do as less actions as possible. We don't user to configure all those dependencies on his own. Murano will attempt to guess the best defaults. Murano will attempt to guess the types of the dependencies between the entities in the environment. For example, if the application requires a database and there is a MySQL entity already present in the environment, Murano will suggest the user that the database should be this MySQL. Of course, user will be able to override this dependency and create another database entity, but anyway, he will not be able to select a Linux node as a database because, well, Murano just makes sure that the types are strong and the entities connected here just follow the requirements, the type requirements. Yeah?
So if you have, in this case, MySQL database and it's going to be on one Linux node, and
it's on two
Linux
Linux
nodes
nodes.
is going to be on another node.
It's possible to configure.
So is it using heat to do that component by component and then overall going orchestrating them? Or is it straight away taking all these as a defined entity and just do a direct implementation?
Sorry, I did not get the
So
question.
you can call heat, ask it to do MySQL first, then do Tomcat, then do MyJava.
On the next slide, I will just show a little bit about architecture and then I'll touch this again. Okay? So, about the architecture, that's our next slide. That's how Murano is built. So, as you may see, we communicate to the outer world via a stateless REST API. That's our central component on this diagram. So this is a regular OpenStack-ish way of doing REST APIs. It's stateless, so it may be scaled up, it may be made high available, it may run on multiple nodes, and it has Python bindings. So it may have multiple clients communicating with this REST API and doing all the Murano actions. As you can see, there is an OpenStack dashboard communicating with the REST API here on this diagram. This is because Murano comes bundled with a plugin to OpenStack dashboard, a standard horizon-based OpenStack dashboard plugin, which provides those rich user experience I was speaking about. We use a standard way of creating OpenStack user interface with those modal dialogues, grids, tables, buttons, with the standard way of building OpenStack UIs. And this dashboard plugin provides most capabilities for working with Murano. It allows to upload the applications to the catalog. It allows to create environments out of those applications, deploy them, and maintain them. But this plugin is not a mandatory requirement. Any other software component may use our Python bindings to communicate with Murano and to use it to deploy environments or whatever they want. So it's possible to imagine a standalone user interface created by some enterprises to just have the access to Murano without exposing the cloud infrastructure of OpenStack itself. Or there may be a command line interface. Well, we're developers, we like command line interfaces. So likely developers will use CLI as a tool to communicate with Murano. And there may be other implementations of client for Murano. Of course, the software, the service-oriented approach is also viable, and you may use Murano as a regular OpenStack service to make other OpenStack services working with Murano. So the REST API is backed by two storages. One is the package repository. It's a core of application catalog itself. It stores the application packages. And another storage is environment storage. That's just a MySQL database storing the descriptions of Murano environments when the users compose environments out of number of applications that's stored in this database. And then, when the cloud environment is ready to be deployed in the cloud infrastructure, it's submitted into the Murano engine, which executes the workflows which are defined in the packages. So when the workflow is executed, it just passes through all the instances, through all the entities of the environment, including the applications and including their dependencies, such as instances, such as networks, such as all those stuff which form the environment. And for each of them, the workflow executes their relevant actions. For some of them, that would be pick the heat template, the snippet of heat, and merge them all together into a big single heat template, and then execute this heat in the cloud. For others, for software components, the workflow may require sending commands to a virtual machine which runs our guest agent. So as soon as heat has instantiated their instance, it has instantiated the virtual machine, Murano agent starts running there, and it starts waiting for the commands from the Murano engine to execute various configuration actions. So the software gets configured after the instance has been instantiated. That probably should answer your question, because when we have multiple instances running the same servers, it means that first we'll have heat templates creating these instances, and then we'll send commands there to configure the software to run on those instances.
You mean the post configuration?
It's not a post configuration, it's post configuration from its point of view, but it's a configuration process, a deployment process from Murano's point of view. Murano resides on top of heat. It uses not only heat, but other workflow branches as well. So eventually our workflow just starts from heat, and then some other actions may proceed.
So what is the level at which it operates? Does it say that it has a YAML descriptor for one application?
We'll have this on demo. I'll demonstrate how the heat template snippets look like. Guys, just one little, please do me a favor. Just ask questions on the questions and answer sessions, okay? Because otherwise, I'm afraid I'll just miss the line in my presentation, okay? So, by the way, there's a demo time. So I think it should answer most of your questions about the heat. So let me just switch to demo. So first of all, I'll show how Murano application package looks like. It's just to be here on the file system. So this is just a folder in my file system containing a number of subfolders, and there is a manifest file declaring the application package itself and describing its contents. That's the entry point into the package. I'll just open it. This is just YAML. You may see that there is a header containing the description, the author information, version information, and some other service data. And then there are references to various files which are present in the subfolders, of application package. So if we just navigate to one of the subfolders, for example, to the heat folder, we'll see a number of heat templates. These are snippets, as I said. For example, let's open this one. This is just a snippet for a subnet, which should be created during the workflow execution of some application when it requires a subnet to run. So this is a heat template in its very first notation, just a JSON. As you probably know, heat may run different kinds of templates. It may run JSON, it may run YAML, and actually two kinds of YAMLs. But this is the oldest one.
Question.
And
Are you supporting heat template?
Can you like wait? He wants you to wait to the end the people in Portland are watching this.
We may support it, but we just have a single syntax now because we need to merge the heat snippets, and if we wanted to support all kinds of heat templates, we would have to merge, to be able to merge different kinds of heat snippets. So for simplicity, we just use a single one, but technically there are no reasons why it shouldn't be possible. So this is a template, but as you may see, it's not complete. It's just a snippet which has a variables inside. That's not heat variables, that's Murano variables. When Murano generates a heat template out of the snippets, it substitutes these variables with actual values which it has discovered during the workflow execution. So in this case, Murano will detect an external network to which the application should join by one of its instances, will detect the network ID by direct communication with OpenStack Neutron, and this network ID will be substituted during the workflow execution inside this template. And then when the template is executed in heat, it will contain already the reference to pre-existing network. So, and one more important thing are UI definitions. A moment. Here they are. This is a UI definition for Microsoft SQL Server. This package is Microsoft SQL Server, probably I forget to say it. So this is a UI definition. That's YAML again, sorry, it opened on a different screen. That's YAML again, and it actually defines the user interface, which should be displayed to the end user when the end user wants to compose an environment, a cloud environment, out of this service, for example, to add this application into the cloud environment. So there are a number of attributes here defining actually the fields in the interface, and the values of these fields map to the application properties which will be used during the application deployment and maintenance in the cloud during the workflow executions. So a number of fields here, we'll see later how they work. So just remember that, for example, there is a Boolean field indicating that the SQL cluster should support mixed authentication model, and there are super user password fields here. We'll see how they work in a real user interface. And there are workflows. The workflows are quite complex XML files. What's going on? Here, let's just see one of them. Why didn't it open? It opened on my screen as well. One moment. Here it is. That's XML defining the workflow rules, the rules which are executed when some conditions are met. It's actually quite a complex notation, but as it's a markup language, it's easy to understand when you get used to it. So actually, we write a lot of this stuff, and it's not as tricky as it may be from the first glance. So let's see how it works in action. Let's see how Murano may deploy this application package in the app catalog, and how may it deploy the application itself in the cloud environment when we're ready. So I have a zip archive here, and so we may just now upload it into our OpenStack environment. Let me just open OpenStack dashboard. Here it is. Now I sign in here. Oh, the session has timed out. Sorry. Okay, here it is. As you may see, this is a regular OpenStack dashboard. Let me just a little bit increase the font size so you see what's happening on the screen. And there is a Murano panel here at the right part of the navigation menu. Here we have a service definitions panel, and this is actually our application catalog, a list of applications registered in our catalog. So you may see that there are a number of Windows-based applications here and a number of Linux-based applications. So let's upload our Microsoft SQL Server application package here. I just press upload service button, choose our zip archive file, here it is, and press upload. It almost immediately uploads because the application package is very lightweight. As I said, we don't always include the actual application binary inside the package. And in case of Microsoft software, there are licensing reasons for that. We are unable to distribute Microsoft software. It's Microsoft's privilege. So we have to distribute the workflows which will deploy them. So our workflows for Microsoft SQL Cluster assume that a binary, an MSI file for Microsoft SQL Server is available at the shared location, and then that workflow will just fetch that binary and use it to deploy Microsoft SQL Server on some nodes. So here it is, as you may see, we have a new item in our catalog here, and if we just use this Manage Service button, you may see that the service definition, which you have seen in the manifest, is now available via OpenStack UI. You may see the headers of this application and their files, its dependencies. You may see there are a lot of files in this package. So now let's try deploying. Let's try deploying a Murano environment. So I'll now act as a user, and I'll go to Users interface of Murano, this Environment tab. As you can see, I have one environment. It's called pre-created. I have created it before this demo to demonstrate to you how the deployed environment looks like, because the actual deployment will take about 30 minutes, and I don't want you to wait till it's finished. So I'll just configure a new one, launch it for deployment, and then look at my homework to demonstrate how the deployed environment looks like. But first, let's create our new environment. So I'm creating an environment. So once again, this is a group of Murano applications and their dependencies. So let it be demo environment. I press create, and my environment is right here. Now I navigate inside, and now I'll be adding applications here. And I want my applications to interact with each other. So we're speaking about the Windows world here, or we're speaking about the Microsoft SQL Server in this example. And well, this is actually quite a complex deployment scenario, because we want to deploy an environment consisting of two Murano applications. One would be Microsoft Active Directory service, which will host a domain for our Windows environment. And another will be our Microsoft SQL Server, which we have just uploaded. So let's compose this environment. Let's compose the environment out of these two applications. I press Create Service button, and this is a list. This is a simplified version of application catalog. Of course, in the next versions of Murano, we'll have much richer catalogization functions here. We'll have ways to filter out the list of applications, to browse the categories and so on. Now it's just a plain list. We don't have too many applications here. And I pick Active Directory here. I press Next. And so this is our wizard-like user interface, allowing to define this environment with specifying only the requirement dependencies of this application. So this thing is going to host a domain, so we need to specify a domain name. So let it be demo domain.local. And well, as you can see, this application allows to create clustered Active Directories, so to allocate multiple instances for it. I don't want to do this, and then I just specify the password of the domain administrator. And the user interface will enforce password complexity requirements here. As you can see, it also shows the hints of what does each field mean, and just suggests the user what to input here. And I can also specify a hostname template. If I just leave it empty, Murano will suggest the randomly generated name for the instance, but I want my instances to look beautiful, so I'll call this AD. Once again, all those fields, they're not hard-coded in Murano dashboard plugin. They're generated according to the descriptions which are defined in the UI file of the application package. We'll see when we will be defining our next application, the SQL Server, we'll see those fields which I point your attention when we are looking at UI description file. Now I press next. As I said, this is a wizard-like interface, so it's next, next, next form. And now it just asks about dependencies of the service. As I said, we just fill in only the necessary dependencies. So the servers depend on the instance. And so we need to pick up the instance flavor, Murano suggested default, M1 medium. We need to pick up the availability zone, Murano suggested default, Nova. And the only thing we have to choose is the image on which this application, this instance will run. We have to choose it because it's Windows, and we are unable to distribute Windows. Once again, that's licensing issues. We don't have the privilege to distribute Microsoft's stuff. And so the user has to select. The user has to first upload this Windows image. Murano will filter all the images available in the cloud. We'll find out that this is a Windows image, and we'll use it. We'll allow to use it in this create service dialog. And then I press create. And the definition of my application is added to this environment. So this is an Active Directory, and it's in the being configuring state. It means that nothing is deployed yet. We just have a description in our environments. It has been saved in the database, but nothing is deployed yet. So we are adding another application to our cloud environment now. I'm pressing create service again. And now I'm picking this Microsoft SQL Server, which we have just added into the application catalog. Same logic, pressing next buttons and navigating through the wizard. You see that this set of fields has changed because this is a different applications, and we have different hints, different field name, different validation rules. So for SQL Server, we have to define the name of the Windows service, which will run on the Windows machine. Then I have to define the local administrator's password. This service will deploy another Windows machine, and I will have to define the administrator password for this machine, the local administrator password. Once again, Murano provides validation rules to enforce the password security, password complexity policies. And now, this is the dependencies between these two applications. Our SQL Server may join a Windows domain, and this becomes a link between these two applications. We host a domain by one Murano application, and another Murano application uses this domain. So here it is. This is a link, remote-domain.local. That's our domain which we have just described in the previous step. I just pick it from this list, and this establishes a dependency between these two applications. And once again, this is not hard-coded. This is just guessed by Murano according to the application definitions, according to application metadata. And now, look at these fields. I was pointing your attention to them while we were looking at UI definition in the application package. This is a mixed mode authentication checkbox, and the passwords for SQL Server Administrator as a user. So I just fill them in, and Murano will execute the branch of workflow which is responsible for configuring Microsoft SQL Server to enable mixed mode authentication and to define the password of SA user in our SQL Server database. And once again, the hostname template allows to give a fancy name to our instances. Actually, when we define multiple instances for a single service, for example, when we have like a load balanced server farm, we'll be able to provide, as you can see on the hint, we'll be able to provide a sharp character to tell Murano that it should generate the iterative sequence of names of these instances. And if I just press sharp here, we have just one instance of SQL Server. This will lead to creation of node named SQL1. Now I press next, and here is the same dialog where I have just to select the Windows image. And I press create. And now my environment is ready to be deployed. And this is those magic button, make me happy. Here it's called deploy this environment. But this actually corresponds to those buttons on your App Store, on your iPhone, where you just click it and have the application installed on your machine. And when I click this button, these two applications will start being deployed in the cloud. This process will take about 30 minutes. I don't want to waste your time. We may just look how the deployed environment look like. I just created the very same environment before this demo. Here it is, recreated. If I navigate here, you'll see. Please open. For some reason, my local machine is quite slow. Yeah, here it is. You see two applications deployed in this environment, and we may actually look for deployment logs here, and you see that actually that's not just click and deploy from Murano's perspective. From user's point of view, that's really click and deploy, but from Murano's point of view, that are a lot of actions which it does. So it creates the instance in heap, creates instances for Active Directory and for SQL Server. Then it configures the firewall to open SQL-specific ports. Then it reports that instances have been created in the cloud stack. Then it applies security templates on various subnets because it has also created all the required network connections and subnets to host the environment, to connect the environment in a single network. Then it creates the primary domain controller on our Active Directory unit. Then it deploys Microsoft SQL Server on our SQL unit. And then our SQL Server starts on the domain controller. So that was the demo. Let's continue with the presentation. I have just a couple of slides left, don't be afraid. That's the current status of the project. We've been in active development for about a year. As I have said, we have started as a Windows Data Center as a service. Now we are already a generic deployment tool with catalog capabilities, and we are going to make Murano full-fledged application catalog according to those requirements I have spoken about at the very beginning of this presentation. We fully support latest OpenStack release, Havana, and we are going to release the new version which will support Icehouse as soon as Icehouse is released. And well, actually, we're StackForge project, we are community OpenStack project. We are looking forward to be incubated with OpenStack, and eventually we want to be integrated with OpenStack. We have quite a long roadmap, quite a long backlog of features. The most important ones include creating a new, easier-to-use domain-specific language. You have seen that XML markup looks a little bit bulky. We want it to be simpler to use, and our application developers will definitely benefit from the new domain-specific language. Another important initiative is we want to store application packages in Glance. This may be a little bit surprising because Glance is used to store images. But actually, we have initiated a conversation with the Glance team, and we have proposed to make Glance not just image storage, but generic artifact storage and metadata storage. So Glance will be able to store arbitrary binary objects with their metadata. This proposal was accepted by the Glance team, and now we are working with them on implementing it. So eventually, probably somewhere in Juno, Glance will become artifact storage, and Murano will use it to store its application packages. Also, we are going to migrate our homebrew workflows to Murano workflow engines. That's the bridge to our next presentation. Renat will take about to Mistral workflow engine. I said Murano?
Yeah.
Sorry, I think about Murano too much probably. To Mistral workflow engine, that's a bridge to our next presenter. Renat will tell you about Mistral. And there are lots of other features which still remain to be done, and we are looking forward to implement them. But the most important thing is that Murano is 100% open source. There is nothing proprietary there, even if some people think so when we say that we used to be Windows. No, we are not. We are not proprietary, and we've never been proprietary. We are 100% open source. And this means that we follow all the community practices regular for OpenStack community projects. So you are able to submit blueprints, you are able to bring your own ideas, you should bring your own ideas and your use cases, all use cases of your customers. And you'll be able to influence the road which Murano will take. As I have said, it's time for OpenStack ready applications. And that guy said developers, developers, developers. And you are developers. So now, you may have your own influence on where Murano goes. And eventually, your own influence on where OpenStack ready applications will go. So, the future of OpenStack itself is in your hands. Welcome to Murano, and thanks for your attention.
Q&As now, right? So
Yeah.
what I'll do so that everybody can hear the question, I'll just give the mic, you know.
Hi, so you mentioned billing initially, but I think what you were talking about is charging, right? You're not talking about printing out a bill and sending it to someone. You're talking about actually recording charges for using software. Is that correct?
Well, it's where we begin. What we do now, we just count statistics.
Do you use
Billing,
a ceilometer for that?
we are going to use Ceilometer. We are going to use our own workflows because when something happens in Murano workflow, it may react on external events, it may react on user input, it may react on some scheduled cron-based event.
Yeah.
Then we may run the
So
workflow.
one of the things I need to warn you about is when you're doing charging and rating, it's a lot more complicated than just simply getting statistics and multiplying it by a number. For example, you might want to give someone a free try before you buy, and then what you have to do is kind of figure out when it's up, and then you have to basically go in and stop and tell the guy that he's got to pay after this point. The other thing is you might want to rate differently according to who your customer happens to be. Like, for example, if you're a bulk customer, you might get a lower price than if you're just a single person, that kind of thing. So my advice to you would be to rather define an API that you can talk to a billing and rating engine and charging engine, and not try to do this yourself, because it's pretty complicated, and if you want, I mean, it's a whole other project to do a billing and a charging and rating engine. I think the thing I would like to see from Murano is an API that could be used to do that somehow, right? Some REST API that would be able to. But essentially, I think Murano would end up being the client side, and the rating and billing, the rating and charging engine would be the server side, right? So.
Of course, yeah, you are right. Thank you very much for this feedback. Of course, you're right. When I was speaking about the billing, I assumed a developer's point of view and user's point of view. User is paying, developer gets paid. So Murano will just gather statistics, and how the actual charging and billing are made is a different topic. They may be part of Murano, they may be not. Actually, there was a number of attempts to make a billing system in OpenStack, probably you know, and none of them were successful up to now. So we don't want to be unsuccessful. We are doing in a very slow pace, we are doing step by step. For now, we just want to gather statistics, and what's more important, to allow our developers, application developers or publishers, to define their own ways, their own statistics, to define their own metrics, which can be counted. So it's also a kind of workflow, part of workflow, kind of. Developers just define the events which are handled and increment some statistics. So how they will be charged, that's a different topic, and it's a long-range topic. But thanks for your input.
Yeah, my question is specific to domain-specific language and the workflow. So, are you using currently Mistral or whatever the workflow engine you are? Are you doing directly the orchestration?
No, we don't use Mistral yet. As I have said in our roadmap, we have plans to do that. Eventually, we will do it because we want Murano to be application catalog. We want Murano to be deployment engine. We want to use various kinds of deployment, orchestration, and workflow engines underneath. But for now, we don't have such good tools in OpenStack ready yet. So for now, we have to do something on our own. Speaking about the domain-specific language, it's a little bit it's a little bit higher level than Mistral's domain-specific language. Rinat will tell you about Mistral's domain-specific language. For Murano, we operate on, we manipulate with Murano applications, application entities. This will be a deep dive and kind of preview because we haven't released this new DSL yet, but I'll just say that it's gonna be kind of object-oriented language for developers, because each application will be represented by a class-like structure having properties, which are configurable parameters, and methods or actions, which will be the workflow events which should be handled by Murano engine. And there will be kind of inheritance. So if you want to create a custom Java application, you will be able to inherit a generic Java application and reuse the common workflow steps which are needed to deploy the generic Java application. So that's just a brief preview. We'll have a set of articles and screencasts as soon as the new DSL is ready. Eventually we need developers, as we with Steve Ballmer say, and we want to educate the developers. We want the people to learn how to write the Murano application packages. So definitely we'll have more on DSL and more on...
So that leads to subsequent question. Do you have any modeling for the application?
You mean the tools?
Yeah, any tools?
Not yet. We have them in our future roadmap. You're welcome to join.
When you showed your demo, I could have envisioned some of the services that you deployed actually being implemented directly on heap templates as opposed to having a workflow engine and then basically instantiating template snippets. So I have to assume that you found a deficiency in heap and that the heap template mechanism that you had to overcome by doing the workflow. I'm just trying to understand what that is.
Yeah, so the question is, why not using heat, why using run, right?
No, I'm just saying,
No.
yes, I could have said that. And I could also say, well, I've seen these massively huge templates, and I assume that the reason you've done what you've done is you've made this process much simpler than trying to do it directly in heap.
The general idea in this question is that we want the thing to be as user-friendly as possible. Of course, everything cannot be done by heat right now. It will be possible to do similar things when heat software orchestration is ready. However, there are some limitations. For example, just as an example, when we deploy the Microsoft SQL Server on in the Active Directory, we have to issue commands. We have to manage the workflow of actions being done on different machines. So first we have to wait till the primary domain controller is instantiated. Then we have to wait till the SQL Server machine joins this domain controller. And only after that we may proceed with the installation. When we deploy something more complicated, for example, we're continuing speaking about Windows, we deploy clustered Microsoft SQL Server using the always-on availability groups and using the Microsoft Windows cluster, which has this high available solutions of multiple instances and quick switching between them. This requires a lot more wait and continue processes. Heat is unable to do that. Heat has kind of wait handles. So you may submit something to deploy on the instance and wait till it's done. So Heat may manage dependencies, but it doesn't allow to return back to this instance and execute something more after something else has been done in other place. I believe that it can be solved. Well, it is evolving. It has a devoted team of very, very smart engineers working, and we contribute to Heat as well in our own purposes. However, the Heat's ultimate goal is different. Heat is a DevOps tool. They have these Heat templates, they have the repository of their templates, these long templates which allow deploying, for example, a multi-node WordPress installation containing the MySQL, containing the front end, containing the back end, containing the load balancer, all those stuff in one template. But then imagine that you want to combine it with some other applications. For example, you want to, you already have the MySQL database in your cloud environment, and you want to use this MySQL database when you deploy those WordPress applications. You'll have to manually modify the template. And that's actually what Murano does. Murano analyzes the environment and generates dynamically Heat template to describe this environment. When Heat is completed, when Heat is able to deploy, to do the software orchestration, we'll just be happy to give all the deployment functionality to Heat, and we will just generate the Heat templates according to the user input. User doesn't have to care about Heat templates, about those various YAML syntax or JSON syntax. User will just click buttons in the wizards, or will compose graphically, you know, as they do in IDE. They just draw arrows between rectangles and saying, okay, this is my Java application, this is my MySQL database, and now we draw arrow, and this is dependency. And this will be turned into Heat template. And still, it's a part of Murano, right? we're still application catalog. So our primary focus remains on the catalog functionality, which is not present in Heat. And it's not Heat's mission to do it.
Hey, quick question. So how would you compare this tool to Puppet, Chip, or Amazon Cloud Formation? Like, what do you use, one or another? Do you see fundamental differentiators?
Have you seen my slides before? Maybe it leaked to internet. I have a homework. Yeah, I have this slide really, because that's a common question. So some part which I have said about Heat also may be applied to the question with Puppet, because Puppet is DevOps-oriented tool, and Murano is user-oriented. And Puppet allows to define the exact environment which you have, and if you want to modify the environment, you have to modify the manifest. And anyway, you have to orchestrate orchestrate Puppet somehow. You have to have Puppet master. In this case, Murano acts as a Puppet master. And one of the best things we have about Murano that we can use various kinds of deployment engine underneath. So Murano eventually is able to run Puppet underneath, to run Puppet as its deployment engine. So it's up to an application developer who develops the workflow, who develops the actual deployment commands to use whatever tool he wants. He may use Murano's built-in scripts, he may use Heat software configuration when it's ready, he may use Puppet, he may use Chef, Salt, whatever is available, just run it, wrap into Murano application package, put into catalog, and it will be working.
Well, our questions in the back of people who didn't have a chance yet. So.
Sure.
Oh, right.
How do you treat failure? So if you have like a 3-node stack and it fails in the middle, do you tear it down and restart, or do you idempotently?
Right now, we report errors. The workflows may define failure handling. In current XML, that's just XML blocks, which we just define some actions which should be done in case if previous block has failed. Kind of try-catch functionality. And once again, it's up to application developer. The workflow may fail gracefully. That's what we do by default. We just report an error. We roll back the Heat stack, and we don't do anything on the virtual machines. We don't send any commands. But as the application developer, the workflow developer, has full control on what's going on, he'll be able to handle errors in a smart way. For example, if a join domain command has failed, then he may send a command to virtual machine telling telling that this virtual machine may need to do something else. I don't know, establish a local administrator with a different password or something like that. So it's up to application developers. We have some patterns, we have some defaults, but it's quite flexible. By default, we just gracefully fail, we roll back stacks, and we report errors in those logs which I have shown you on the demo.
We'll do 3 more questions from this audience if exists, and Sean is checking other questions online. So.
Yeah, I think we lost to the guys in Portland.
They had to go get some beer.
How do you, can you comment on how do you plan to handle application patching, versioning, upgrades? Is that going to be in the roadmap?
Yes, sure. As I have said, it all starts with application developer in the cloud, but nothing ends here. So application catalog should provide unified ways to manage application life cycles. That's important. I think I was saying about the scale up, the data migration, and the backups as a common task in the cloud. But actually, the patching is also a common task. So the application developer, when he develops the package, may already at this point when he develops the initial package, may include the workflows which allow to execute some actions with the applications. He just defines the workflows to handle event, and this event is patch available. And then Murano API is called with information that this event is triggered, and it is passed to the workflow engine, and this branch of workflow is executed, and all the actions which are needed to apply the patch are executed against the application. Another thing is that we may patch the packages themselves. I mean, the new version of a single application package may appear. That's in the roadmap. We expect to have versioning of application packages. So the application developer may patch the application package itself, may include new workflow steps and update the package in the repository, in the catalog, and then the users will be able to redeploy their cloud environments, and the new packages will be applied, new versions of application workflows will be applied to existing instances.
2 more. Yes, 3 hands, so we'll do 3 more questions. 1, 2, and 3.
Thank you. I'll ask a business question. By the way, very nice presentation, thank you. And I agree with your developer comment. But if you look at app catalogs or app stores, the reason that they actually become popular and people actually build millions of apps for Android or others are 2 reasons. One is it's a public place where everybody can upload, create their own apps and upload, and it becomes available to all iPhones, right, or all Android phones. What we're talking about here, correct me if I'm wrong, is a catalog that is deployed with a single OpenStack deployment, right? Or is there a public store envisioned as well? What's happening in OpenStack in that case?
Well, that's a correct observation. Thank you very much for this question. That's true. For now, we speak about the application catalog which belongs to a single OpenStack deployment. However, OpenStack deployments tend to become large. I mean, if there is an OpenStack deployment sized as Amazon, it will be quite public, right? Quite wide. So, and I believe that OpenStack will be of comparable size with Amazon. However, of course, OpenStack is very good for private clouds, and we are going to have much more private clouds than public clouds. And when we initially designed the concept of Murano as application catalog, we considered that this catalog, that can be appearing between different catalogs. So public cloud hosters, the large ones like Rackspace or there are a number of public cloud hosters, may host a repositories, cloud application catalogs which are public and which may be peered, like daisy chain linked with other application catalogs and maybe with the private ones. So it is in the roadmap, but it's still in a far away roadmap, because for now we want to fully implement the minimum viable version of what we call application catalog, and so for now it's local. But of course we want to have, actually it should become kind of package repositories they have for Linux systems.
I'll add 2 cents to this, since it's a business question. So, I don't know how many of you are following some of the work that we're doing in the community, and the folks at the OpenStack Foundation know it well, and a lot of vendors know it, but there is a project that Mirantis is pushing in the community that will do the kind of the vendor certification dashboard. That will be kind of an extension to Stackalytics, and all the vendors will be able to go and actually run their drivers and their certification through the CI/CD environment inside OpenStack, and then you can see which, it'll run continuously, and you'll see which build of what version driver will be actually executing and so on, and then you will be able to get the certification straight from the foundation. So let's say if you are a driver for storage, a Ceph driver, right? You will see you're certified for this versus that to all the level of testing, including functionality, including scalability and the like. So this is possible now to do because we understand how to do it. The CI/CD environment is there, and the tooling is all there. So Murano will provide the tooling for applications, and ultimately, if it's standardized, then we can do the OpenStack certification just the same way, right? But you can't do it until the infrastructure bit is there. So they're just kind of building the infrastructure. Thank you.
Can you compare Murano to Cloud Foundry?
Somebody read my blog.
Yeah, we used to. Actually, we have contributors who contribute to Murano just because they have a goal to get rid of Cloud Foundry. So for me, it's a compliment to Murano. Of course, the main difference between Murano and Cloud Foundry is that we have different approaches to the way how application catalog or the PaaS solution in terms of Cloud Foundry integrates with the infrastructure as a service vendor. Cloud Foundry is generic. It may run various clouds underneath. And because of that, it's separated. So it's a good approach, and it has its meaning. But they're separate, they're split. There is a Cloud Foundry, and there are other infrastructure as a service solutions. Murano wants to be part of OpenStack, an integral part of OpenStack. We know how OpenStack works, we know how OpenStack core components work, and we integrate with them in much tighter way. We know how they work, and we optimize our workflows, we optimize our engines for the specifics of OpenStack components such as Heat, such as Neutron. Of course, we use the same APIs, but we are part of the same ecosystem, and this gives us benefits. Of course, we cannot target other infrastructure as a service solutions as Cloud Foundry does, but at the same time, we are able to do the best on OpenStack. And being part of OpenStack Foundation, as Alex has said, gives us other benefits which are impossible for third-party commercial solutions, which are not upstream OpenStack solutions.
So I think that both will have their space. I mean, history shows that when you actually work the stack, right, those who have control of the bottom of the stack will then build a much tighter integration with the places up the stack. And the natural proclivity of technologies that are starting down the stack, they have to move up, because once the bottom part commoditizes, the value moves up. And if you look at the history of like Microsoft, for example, right, they started with the bottom piece, but then they moved into tools, which is the olden days PaaS layer.